Dear friends, welcome to this electrical engineering knowledge sharing channel. We are discussing about the switchgear control schematics under workshop 8. This workshop 8 is nearly at the end of this discussion. Today we are going to discuss about the final part of the switchgear, that is how the switchgear is connected with various field equipments. We know the switchgear is a bulk power equipment. The job of a switchgear is to receive the bulk power from the generating source or from the grid, and this bulk power instantly distributed amongst the various load or various power equipment which is connected to this switchgear. So this switchgear acts as a intermediate equipment or as a mediator just to receive power from the generators or from the grid, and immediately and at the same time it is distributing the same amount of power to the various field equipment or various power equipment which is connected with the switchgear and is required to continuously and satisfactory running of the plant. So these various field equipments is connected with the main switchgear through the cables. So how the various cables which are connected with the switchgear, how we can represent of these various cables. Now when we talk about the cables are electrical cables are mainly divided in two parts. One is a power electrical cable, another is a control electrical cables. So the power electrical cable will be dealing separately, control electrical cables will be dealing separately. Now the power electrical cable, again it is divided into two parts. One part is the voltage grade for which the switchgear is designed. That voltage grade cable which is carrying the major power to the various field equipments, that is one of the power cable. Then there is another two category of power cable, that is a small power cable, that is low voltage power cable, which is actually supplying the various AC and DC control power to the switchgear. That is also another power cable. And third power cable is a low voltage power cable that is carrying the various AC signal, that is like a CT signal, PT signal from the various field equipment to the switchgear. So these are the three different category of power cables. That power cable will be discussing in one session, and these control cables will be discussing in separate. It may happen in this discussion we may include only the major power cable and the CT or PT cable which is coming from the various equipment to the switchgear, and the control power cable or the power cable which is used for the control power purpose, that we can discuss under the control cable section. Now these various cables which are connected with the switchgear amongst the and to the various field equipments, these various cables, there are so many equipments in the field. Suppose this particular switchgear which we are considering has a 25 panels. So from what it is consisting of 25 panels, each panel is dedicated to a particular field equipment. That means there are so many 25 or more numbers of cable will be there. So how we can represent all this cable in a single diagram or single drawing, that we are discussing. Normally all the field power cable, major power cable which are connected to the various field equipment, we represented by the cable block diagram. That means if we say what is cable block diagram, cable block diagram is a pictorial representation of the various field cables which are connected to the various field loads or field equipment, power equipment, as well as to the generators or the grid, which are connected. Those power cable on the drawing which are represent on which this all the power cables are pictorially represented on the drawing. That drawing which is called the cable block diagram. So we will be representing the all equipment in the block form, and these blocks are connected by the cable. That cable details will be shown on the drawing. That is the cable block diagram. So when we represented the cable block diagram for the power cables, we say it is a power cable block diagram. If we represent the block diagram for the control power cables, then we say control power cable diagram. Similarly, when we represent this control cable, all the control cable, we say control cable diagram. So this way the cable diagram are designated. Now what we can represent in a cable diagram or cable block diagram. In the case of power cables, it is easy to represent all the power cable and these various information on the same drawing. Mainly four important information we generally try to represent on the power cable block diagram. Number one, the major equipment from which these cables are originating, the mother equipment and associated with all the field equipment we represent by the block form. That is number one. Number two, each equipment, each field equipment, what is the size or what are the size or type of cable is connected by this, that the cable details also we can represent on the cable block diagram. Then how much length of cable for that particular cable, that also we can represent on the cable block diagram. And then how the cable is laid in the field. There is a different ways we'll discuss one by one. The mode of laying of the cable also we can show on the cable block diagram. And in addition to this, each cable has an identification number. The identification number also we can show on the cable block diagram. So these are the 4 or 5 major important features which we can represent on the cable block diagram. Somebody may say, why I need a cable block diagram? I have a single line diagram. In the single line diagram, that means which is produced by the consultant or by the company. This single line diagram also contains the cable details, size of the cables. But all other information may not be possible to represent on the cable single line diagrams. That's why cable block diagram is another important document for working at field. Now, to produce the cable block diagram, we need some important reference document. That reference document, what is that? That is your cable sizing calculation. Now, the project has a different phases. When the project is initiated in the conceptual stage or in the front-end engineering stage, this company generally decide what are the various plant equipment is required to start the plant, what are the various loads and equipments, what are the tentative layout, and what are the various cables required, that also identified in the FEED documents. So, and if you look into the FEED document or the conceptual design document, you can see there is an overall layout of the plant. In that plant, all the field equipment, major equipment, everything is tentative location are shown. Then, based on the tentative location and the size of each equipment also decided in the FEED document or the conceptual design document. From the size of the equipment and the length, most of the company in the conceptual stage, they calculate the cable size, and from that cable size there is a document, cable size calculations. From that document, this document is important to develop this cable block diagram. Cable block diagram we generally developed at the detail engineering stage using the front-end engineering document. So based on the front-end engineering document, we first prepare the cable block diagram as a draft. Then, and it is done in the detail engineering stage when the project progress is in the upper level. With that document, we travel to the site, we look into the actual condition of the equipment, because detailed design or this construction engineering will be carried out at a stage when most of the equipments are finalized. Means most of the equipment finalized, tentative location is finalized, so all the length are more or less finalized. Based on that, we recheck all the cable sizing calculation which was part of the FEED document, and even if further revision is required, we do the revision, and based on the revised document, we finalize the cable block diagram. So this is the way cable block diagram is made, and this cable block diagram helps a lot to the site construction team to lay the cable, to overall visualize how many cables are there and how the cables are considered to be laid, and what is the various length of the cable is required. That is also we can show on the cable block diagram. In addition to this, from the cable block diagram, because as all the power cable are originating is coming from the various field equipment, ultimately all are terminating where it is coming to the heart of the plant, that is on the switch gear. So the switch gear, from the cable block diagram, immediately we can make out how many cables are coming to the switch gear, what would be the cable entry provision we need. This all the field cable which is coming from the field, from the various equipment, whether it is power cable or control cable, ultimately all the cable is coming to the heart of the plant, that is the switch gear. So the switch gear, this cable either come from the top or from the bottom. So this bottom, what is the, each panel has a bottom, there is a bottom gland plate, we call it gland plate, through which the cables are coming. So what size of cable gland is required, what is the hole size on the gland plate is required, what is the gland is required to take the cable through the gland plate, all these things we can decide from the cable block diagram. That's why the cable block diagram is very important document for the field construction team, so that they can easily decide what mode of laying arrangement, how many cables are coming to the switchgear, what is the entry provision, how much length are there, what are the various size are there, all this thing is there. So that's why the cable block diagram is important parameter. So today's video will be discussing only the power cable block diagram, concentrating on the major power as well as CT-PT power, which is coming from the field to the switchgear. Here switchgear is a mother equipment. I have shown the switchgear over here. This is the 11 kV switchgear, which is consisting of 25 panels. Means therefore that means in the field there are total 25 or more than 25 cables, because one equipment, if it needs two numbers of cable, then the number of cables will be more than the panels, but minimum 25 cables will be in the field. So this is all the cable is coming ultimately at the switch gear. So this is the major power equipment which is receiving power from where we have considered 4 number generator 2 into GTAB. This is the symbol of the generator. We use here various symbol. Generator symbol we have used like this. This is the generator symbol. This is AC generator, and this is a AC motor. This is the AC motor symbol we have used. This symbol means this is a transformer. This is the symbol for the transformer, and this is the substation. These are two are substation. These are the symbols we have used. In addition to this, we have used the symbol for the various cables laying method to represent how the cables are laid. We have considered 4 different laying method. One laying method is a cable laid on the tray. It is an overhead tray or above the surface tray, cable laid on the tray, metallic tray or PVC GRP tray, whatever it could be. So that cable laid on the tray is represented. This is the cable, and below the dot that represent this cable is laid on the cable tray. Okay, so that means if we look into the cable, this is the typical cable block diagram. I have drawn it. So now if we look into this cable laid on the tray, where it is, this is one of the cable laid on tray, this is one of the cable laid on tray, this is one of the cable laid on tray, these are the cable laid on tray, this is the cable laid on tray. So this is the symbol depicting which cables are laid on tray. Then the second method is a cable laying. We can lay the cable under the ground directly without any support or directly we can make a dig, and we can make a tunnel and the underground. Then we can put the cable, then we can fill up with the soil in other tiles and all these things. That is we call directly buried cable. Directly buried cable, this is the cable. Directly buried cable symbol we have used, both top and bottom are dotted. This is when this symbol is there, this means this cable is directly buried like this. This is one of the directly buried cable. Then this is one of the directly buried cable. These two cables are considered directly buried. Then there is another symbol we use, that is in the case of cable buried under the ground, but it is not directly buried, it is buried. This cable has laid in a concrete trench by a duct bank. How it is that we make a concrete duct, like it is a concrete duct, inside there is a pipe. These are the concrete block, it is a under the ground, okay, and through this duct, through this pipe, this cable is passing, okay. This is mainly we use in the oil field. When the oil field is on the land, normally we put this cable in like this type of arrangement to protect from the environment. This is a duct bank. Suppose this is one of the cable we have considered laid on duct bank. How is that symbol? We have shown the cable like this. Then top is a soil, bottom is a soil, and inside these are the duct bank. This is the symbol of the concrete. So this is the symbol. What this symbol is there means this cable is laid in a duct bank. So this cable is laid in duct bank. Then the fourth symbol we have used here, sometime the cable goes through the subsea. When the cable goes through the subsea, we use subsea cable. The subsea cable, when we put, there are 2 ways we can lay the subsea cable. One is the directly laid subsea cable, another is a trench subsea cable. Here we have shown a directly laid subsea cable. Here the subsea cable laid directly on the bottom of the subsea. So that symbol, this is the cable, bottom is a dotted line and top is a wavy. Wavy means it is a water wave. This way, if we represent that, you understand this cable under the subsea cable. This is a subsea laying cable. This is the subsea directly buried on the subsea bed. This cable laid on the subsea bottom, subsea bed, the cable is living. So this is the 4 different way this cable can be represented to represent their laying method. So here we have considered 4 different methods. Okay. Now, how we are representing the cable block diagram that I have shown now. You see, these are the various symbols we have used here. Now, this is how the cable block diagram is made. This cable block, this is the master equipment from where all the cables are originating. So this is the power source, you can say indirectly. This device or this power equipment, this switch gear is connected with a 4 number of generator. Here, this 2 into GTAB means this is the identical generator. The generator is 2 number and the tag of the GT is GTA and B. There are 2. If you have a space, you can put all the 2 generators separately. As I have a limited space, that's why I have represented in this way. Then there is another 2 generators. This is another 2 generator which is tagged as a C and D. Suppose this generator is are 7.5 MVA generator. Okay. This is we are considering 7.5 MVA 11 kV generator. These 2. And these 2 are suppose this is a 15 MVA 11 kV generators. So these are the total 4 generator. 15 MVA 2 number means 30 MVA production, and here 7.5 MVA 2 MVA and 15 MVA, total 45 MVA power generation we have. So this power is coming to the switch gear. Then this 40 MVA, out of this 40 MVA, maybe at particular instant I have a 30 MVA requirement. The 30 MVA is connected, this 30 MVA load is connected. So these are the various transformer. These are the transformer. There are 2 number transformer, similar transformer that is tagged as A and B. There are another 2 number transformer which is tagged as C and D. There is another 2 number transformer which is tagged as E and F. So there are total 6 number transformer. We have a total 4 numbers of motor. Suppose this motor is a 3 megawatt. This is the 4 megawatt. This is a 5 megawatt. It is a 6 megawatt. So these are the 2 numbers of motor is there. Suppose it is a 3 megawatt motor. This is a 4 megawatt motor. This is a 5 megawatt motor and this is a 6 megawatt motor. So this is a total, this total 8 numbers motors are there, 6 number transformers are there. In addition to this, we are considering the entire plant. This portion of the plant is located on an island. So this is an island. So in the island we have the ground. So all this provision is there. Now this is a from this island we are considering there is a 2 offshore platform where we have to, that is the offshore platform means those location is inside the sea on the platform. There is a 2 same 11 kV substation which need power. This is a 2 11 kV substation which need, suppose this substation is from this island, this 2 is as a 5 kilometer away. We are considering in this way. 5 kilometer away there are 2 substations. Those substations need the power. At the offshore platform, they don't have the generation facility, so they are receiving the power through the feeder at 11 kV. So there are 2 offshore platform which is receiving power through the subsea cable. That is each substation is receiving 2 cable, because you know subsea cable we never, though there is only 1 power cable is required, but always we put 2 cable, because if 1 cable fails then other cable will be there. So that's why it is considered 2 numbers cable. So these are the various loads we are representing around the main equipment. Then each equipment is connected to a power cable. Then this power cable, mainly 3 information we put along the cable size. One is, what is that? I am showing one of the typical. Here you see these are the 2 transformers we have shown over here. So there are 2 number. These first 2 is representing how many cables are there. Then what is the number of core, because this transformer mainly it is a delta star transformer. These transformers are generally considered delta star transformers. So primary side 11 kV side is star, 11 kV side is delta, and other side is a star. So delta means I need a 3 core cable. So this is a 3 core cable. So 2 number 3 core cable. What is the cable size I have considered? That is a 240 square millimeter. It is 11 kV grade cable. Okay, 11 kV cable, 2 numbers cable, because there are 2 transformers. That means each transformer how it is connected. Each transformer here is suppose transformer A. How it is connected? It is connected into one number 3 core into 240 square millimeter cross section. This is the cross section of the cable, copper cable with a XLP insulation. All the detail I can write over here. So from this I can make out this transformer is connected from the switch gear with one power cable. That power cable is a 3 core cable, 240 square millimeter copper and XLP insulated cable. So as there are two transformers I have shown over here, two number 3 core. Okay, and this symbol indicates the cable laid on the cable tray. Then third part is this cable, how much length from here to here? Suppose the length is transformer A and B length from the switch gear is a 500 meter. So what we will do? We will put over here 500 meter. This is a 500 meter length. Then this cable should have a tag. Yeah. To identify this cable, how this cable tag will be made? There are two equipment is connecting. One is a switch gear. This is a switch gear. Suppose this switch gear tag SWGR1. Suppose this is a tag of the switch gear. This switch gear 1 is connected by the power cable to whom? Now this transformer TRA, right? So what we do normally, the power cable is originating from here. Actually, this is the source. So first when we put the tag on this cable, we put first switch gear tag SWGR1 colon. Where it is going to transformer A. So we put transformer A. Then we put some number over here. Suppose this is the first cable. We are considering this switch gear has so many cables. This cable is considered the first cable. So we will put P1. So from this tag, we can make out, this tag will be appearing over here. This tag we can make out if we see there is a cable over in the field and there is this cable tag is provided over the cable. From the tag I can make out immediately this cable is coming from switch gear 1, that means this 11 kV switch gear. Where it is going to transformer A. Transformer A is this, and what is the cable number? P1. So I will go to easily we can identify this cable tag. This is the cable tag, and then from the cable P1 I can make out, from when I go to the transformer I can see the cable size. It is written 1 3 core. Then I open the drawing, I can see this cable is a 3 core 240 square millimeter cable. This cable is a 3 core 240 square millimeter cable is connected. So these are the information I can put over this. Similarly here the same thing. Here I have a two transformer, tag is C and D. So here instead of A it will be C. C or D, suppose C. Here cable size is, what is the cable size? Here cable size is a 300 square millimeter. Now this cable tag, this is a P1. So this cable tag I will put here, instead of P1 I will put P2. So P2 means it is connected to transformer C. Okay, it is connected to transformer C. Similarly, transformer D will be maybe P3 or P4. I can give the tag accordingly. So this way each cable has a tag. Now in case of single core cable, suppose here this generators, okay, this generator is a 7.5 MVA generators. To cater this power at 11 kV, if I use a 3 core cable, suppose this cable size is a 630 square millimeter cable. Now if I want to use 630 square millimeter 3 core cable, problem is 630 square 3 core into 630 square millimeter cable, okay, with a XLP insulation. If I take this one number 3 core cable, the diameter about 250 millimeter, about 200 millimeter plus, about 4 inch to 5 inch diameter. So such a big cable with this size will be like this. This size of cable laying, we can lay it, but problem will be coming at the two end. Two end means at the generator end and at the switch gear end. Ultimately, this cable will go through the field. This cable has shown cable laid on the tray. From the tray, this cable will entering into the switch gear. Now we have to bend the cable to the switch gear. Similarly, in the generator end, the cable will be coming over the tray and then it will be dropping on the wire. It will be laying from the top to switch generator terminal box. During that time, the cable need to bend. So to bend this cable and enter the cable inside the terminal box for such a big cable is difficult. That's why for such a huge size cable, we generally do not use a 3 core cable. We generally use a single core cable. So here we have shown that way. There is a, this is a 2 means there are two generators. That's how we have put these two. Each generator, how it is connected, 3 numbers. We have written 3 numbers, 630 square millimeter cable per phase. That means How the generators are connected here? Each generator per phase, generator is 3 phase, red, yellow, blue. Suppose this is the terminals. Each terminal here, there are 3 numbers. We are putting 3 numbers, single core. Here these cables are single core cable, 3 number per phase. That means 3 numbers, 3 into, you can write down in this way, 3 into 1 core into, or 3 dash, you can put 3 dash over here, 1 core 630 square millimeter per phase, not the total equipment, per phase. 3 number single core 630 square millimeter cable is connected per phase. That means if I consider one generator, then how many cables will be there? So 3 phase total 9 numbers. 9 numbers, 1 core into 630 square millimeter cable for each generator. So there are 2 generators, total 18 numbers cable will be here for 2 generators. And suppose this length from the switch gear to generator is a 200 meter. So L will be 200 meter. And then if we want to put the tag on this cable, how we'll put the same way? It is coming from the switch gear SWGR1, okay? SWG1, this is the switch gear tag, SWG1 switch gear, colon, where it is going, suppose it is going to GTA, colon. Then suppose this cable number, I am giving the cable tag P5. Now here is the problem. Now P5, now it is not the one cable. There is a 9 numbers cable are there. 9 numbers cable. So we will put P5-1, P5-2, P5-3, P5-9. Okay. Otherwise, we can do another way. P5R, P5R, P5-1, P5R, P5Y. Sorry, it is also R, P5R. That means from there you can make our R phase. There are 3 cable. Then P5 dash Y, then P5 dash Y, P5 dash Y. Now 3 number Y. Similar blue will get P5B, P5B, P5B. From that you will make out P5 cable per phase. R phase there are 3 number cable, Y phase there are 3 number cable, and blue phase there are 3 numbers cable. That way we represent in the case of single core cables. Okay. So that representation will be here. These are the cable, how the cable number is represented. Now in the case of subsea cable, how the cable is laid. Now this we have, for simplicity, we have shown in this way. But actually subsea cable is not laid in this way. Subsea cable, if you look the subsea cable, it is actually multiple combination. From the switch gear, this switch gear is located in the land, right? Now from the land the cable is going. Then that cable, the cable which is laying on the land, that cable cannot go through the water. So water cable means subsea cable is completely different. So that's why on the land, actual arrangement, this is the switch gear. From the switch gear, the cable is coming. Suppose it is coming over the tray. Then there will be a junction box over here near to the subsea. This is a junction box. This portion is a subsea. So what will happen? There is a subsea cable from here. This is a subsea cable. Okay, this is a subsea cable. Then it go to the substation end. There will be another junction box on the platform. There this subsea cable will be terminated, and from there the cable will be laid on a tray, and then it will go to the substation. These are the actual arrangement. So this cable, it is also, suppose it is a 240 square millimeter cable. This cable also 240, 1 3 core 240 square millimeter cable. Okay, this part, and this part also 1 3 core 240 square meter. This length is 25 meter. This length may be 50 meter. Okay. Now this subsea portion, it is a 5 kilometer. But this subsea cable, normally we do not take only one power cable through the subsea, because when this substation is working, taking power from 11 kV in the island. So lot of signal is coming from here to the 11 kV. Not only the signal, not only electrical signal, electrical instrumentation, various type of signal is coming from here to here. So to transmit this signal, we need some electrical control cable, and for the instrumentation data, telephone data, because this substation is 5 kilometers away inside the sea. So we need to communicate with this, either telephone communication or any other mode of communication. Sometimes we may need another Ethernet communication. So all this communication will be done from here to here through the fiber optic cable. So that means this subsea portion cable, this is only one cable, but that cable consisting of three different parts. What are the three? And I am deleting this part. What are the three different parts? One part is a major power cable. That power cable is, we have already shown, it is a 1 3-core into 240 square millimeter cable. That is one major power cable. Okay. Then it may require one number, suppose 24 core into 1.5 square millimeter control cable. Then it may require one number 24 fiber consisting of fiber optic cable. These three cable together is coming as a composite cable. So this is that composite cable, this subsea cable, that cable laid on the seabed. Okay, these are the three different cables. So from this cable, so from this diagram, if I develop this block diagram in this way, immediately from the block diagram I can make out how many cables are there, what are the various size of the cables, how the cables are laid, what is the length, what is the cable tag, and how many equipments for the switch gear. So this is for 11 kV cable block diagram. Now in a particular plant, if you have a multiple levels, suppose there is 11 kV switch gear, there is a 6.6 kV switch gear, there is a 415 volt switch gear. In that case, what do we need to do for each voltage level? Because 11 kV, as 11 kV switch gear is connected with this so many loads, similarly 6.6 kV switch gear also will be connected with the various types of load. So for 6.6 kV also we have to develop the similar cable block diagram. If we go to the 415 volt, we can develop the we have to develop the 415 volt switch gear cable block diagram in the same way. So this way we can develop the cable block diagram, which will be useful tool or useful drawing for the various points of view to understand what are the various types of cable, what is the size of the cable, what is the length of the cable, what is the mode of connection, what is the mode of laying, and how many cable is coming to the switch gear, what is the cable entry provision required, what is the size of the gland, what is the size of the lux. All these things we can make from the cable block diagram. In addition to this cable block diagram also, in this diagram also we can represent the CT cable. Like I am giving one example over here because we have a limited space. Suppose I am deleting this part. So suppose this is a switch gear. Now this switch gear, how the CT cables are coming into picture. In the same diagram where we have, this is my switch gear, this is the switch gear we have shown, right? This is the switch gear. Now in this switch gear we have and this is our generator skid, right? This is the generators and this is a switch gear. We have shown this is I have a power cable laid on the cable tray. This cable we have already shown, it is your 9 numbers 1 core into 630 square millimeter cable. Now this generator, if you see the generator winding, this is the generator is the 3 winding. So this 3 winding is ultimately connected to the terminal box, right? Now when we protect the generator from the generator differential, then this is winding, this generator 3 winding, right? These are the 3 windings of the generator, right? So this is the star winding. Now if you see the generator differential, there are CT over here. This CT we put in the switch gear, okay? But in the generator neutral side, before forming the neutral, there is a CT over here. In this location, there are 3 CT. This CT is in the generator, inside the generator on the generator terminal box. From that CT, because if we protect the generator by generator differential protection 87G relay is located in the switch gear. So this CT supply need to come over here. One set of CT over here. That supply is coming to the relay. But this field side CT supply need to come over here. So there will be CT supply requirement here. So generally this CT supply is we did a 4 core cable, maybe 6 square millimeter cable for the differential. So this 4 core CT cable also required over here. And in addition to this, if there is if the line PT, this generator also for the synchronization purpose, when this generator power coming to the switch gear, we have to synchronize the switch gear breaker. So in that case, what is happening? How we synchronize? We synchronize generator PT and the bus PT by sensing this PT supply. If this generator PT, you know how the generator is connected, we have already discussed in the generator protection. If you look into the generator protection, you can see that suppose this is the generator and it is coming to this is a switch gear breaker, okay? This is a switch gear bus bar. So there is a PT over here, this PT supply, and before the breaker, there is a PT over here. This is a PT. This is we call line fitting. Now this breaker will be closed. This breaker, suppose this breaker is open. At this moment the breaker is open. Now this breaker to be closed by sensing this PT supply and this PT supply. And this sensing synchronizing arrangement is in the switch gear. So if this PT, this is called line PT, this is called branch PT. If this line PT is located in the switch gear, in that case PT supply is not required. But if this PT is lying on the generator terminal here, in that case from the generator will be another cable will be coming, that is for the PT supply. That may be 4 core into 2.5 square millimeter, another power cable is coming for the PT supply. So this cable also to be shown over this drawing. So that also we can lay, and length and all this thing is already there. So from there, and these are the separate number also that we can include. So these, so in this way, this power cable block diagram can contain the major power equipment, major power cable, as well as the CTPT power cable also we can show over this cable block diagram. Now in addition to this cable block diagram, that drawing, we can make a small table on the right side of the drawing or on the bottom of the drawing to demonstrate the summary of the various cables, is laying method, and the estimation of the various types of cable. Suppose in a particular switch gear, I have a 5 different size of cable: 185 square millimeter cable, 240 square millimeter cable, 300 square millimeter cable, 400 square millimeter cable, and 630 square millimeter cable. These are the 5 different size of cable I have in the plant for the 11 kV switch gear. So what we do, we make a small table at the bottom of the drawing. How we make that table? Suppose we will be making the table in this way. I am giving just on a draft. Suppose this is the first column, we make a serial number. Second column, we give the load details. Load details means equipment, field equipment details. Third column, we will be giving the cable details. We will write down over here cable. What is the cable size and cable details? Okay. Then we will put over here mode of laying. How the cable is laid. Mode of laying. When a cable is laid directly underground or subsea, or it is laid on the cable tray, that we can mode of laying over here. We can put it cable. Then we can put it over here, that length of the cable. Okay. And the type, cable type. Suppose we have a cable type. Suppose this is a first 185. Suppose we are considering 185 cable. So what we will do, from the cable block diagram, we will collect all the 185 cable equipment. So that first type is a 185 square millimeter. The first serial number 1, we put the load details over here. Suppose this load is a transformer. The cable is a 3 core into 185 cables. Okay. Then mode of laying, it is a suppose laid in tray. We write down laid in tray. Length is suppose length equal 500 meter. Okay. This is a 185 cable. That is one. Second, we'll go to another equipment. In this way, whatever the 185 cables, we leads down over here. Then we'll put a sum over here. That is a sum. How much total length is coming for this 185? So 185, suppose is coming 2.5 kilometer. So I have a reference that 185 cable is required, sum of 185 square millimeter. Okay, that is a type 1. Now we go to the next. We are going to type 2. Type 2 is a 240 square millimeter cable. Similarly, suppose this is go up to 10. Then cable 11 will go like this. Here also we can add another column. Here we can put the, if we want, we can put a cable number over here. Type of the cable, we can make 2 column, cable number, which we have already decided. We can put the cable number, switch gear 1, colon, then transformer A, colon, then the P1. We can put this number. Similarly, all the cable in this way, we can make a table. From the table, each cable details are there, as well as the total type, each length of cable, how much required, that is also we can make out. So ordering of the cable or procurement of the cable, how much cable has procured, how much cable is required, we can easily check, and accordingly if any further additional cable is required, we can easily identify. So these are the another use of the cable block diagram. So in this way, I am closing the cable block diagram session over here. In the next session, we will be discussing about the control cable block diagram and the further application of that. So this is the, so with this I am closing. Thank you very much indeed, and please go through this. If you have any queries, please come back to me. Please take note that after the next video, our switch gear schematics will be completed. 2 things I have not shown under the switch gear schematics. Number 1 is your about the single line diagram and the 3 line diagram. These are considered a AC diagram, as that is not part of the switch gear. That's how I have not considered that thing. But if somebody wants to know about the single line and three line diagram of the switch gear, then please put a comment, then I'll try to respond it. That is all about the switch gear control schematics. And after that, we'll be maybe starting the UPS system. Please go ahead and please follow up with the various videos. It may helpful to all of you. And if we make any help to you, that will be my pleasure. Thank you very much indeed. Thank you.